engine. That was a tag here.
My sound is off too.
That was a tag function I wrote to add infinite feedback to this template. So there's one other sort of ancillary benefit that we can get from tag templates, or sorry, from template literals, and that is JavaScript allows you to use single or double quotes. It's unopinionated for strings, right? So what usually happens is a team picks a standard and they let a linter enforce it. And every once in a while, we're going through our build and we get an error like this, as we forgot, or we copy pasted some code from somewhere else that had the opposite style. So one of the possibilities here, and we're exploring this in Agilysys, is just to use backticks everywhere, right? It eliminates this problem, and in the mix, we also get string interpolation, multi-line strings, escaping of characters without, or special characters without escaping. It seems like a natural win to me. And the last piece of syntactical goodness I want to talk about in ES6 is modules, and this is the most important in my opinion. So just like with block scoping, this language went 20 years without the concept of modules, right? Most other modern languages rely on modules as a basic building block for building applications, but we just have not had them. And over the years, the community's come up with some creative solutions to this problem. We had things like object namespacing, right? Immediately invoke function expressions, the JavaScript module pattern. We finally got true modules on the server with common.js and in the browser with AMP. And my personal favorite solution to not having modules in JavaScript is script tag module, right? We've all seen something like this. This, in fact, is a snippet from an Agilysys application, which I dare to show to you here to illustrate that all teams can make mistakes. But what's really cool is ES6 gives us native modules. There's just one problem, and that is a loader didn't make the cut. So we have this native syntax for defining modules, all sorts of syntactical goodness, no way to load them in a browser. So the community, and I believe it's an amazing community, has stepped up to the plate and created some amazing tools, right? Some of which take advantage of what this new syntax gives us, like the ability to do static analysis and tree shaping. Right? Ultimately, though, module loading is now starting to appear in the experimental builds of popular browsers, but we have to resign ourselves to the fact that until HTTP2 is widely rolled out, and we have aggressive server-side caching of these modules, that we probably are going to be looking at module bundling for the foreseeable future. So we've talked about syntax. Let's talk about enhancements. Right? We have some enhancements to the standard library of JavaScript, starting with strings. So most of these enhancements are not really groundbreaking, right? And they don't save us that much in syntax. What they do, though, is give us a much more clear expression of intent of what we're trying to solve with this problem. Same thing with starts with. I would argue that ends with gives us a much more robust syntax as well. And none of these, though, are really groundbreaking. Same thing with array. Array gives us a few interesting methods. I do think array.find and its cousin find index are kind of important. These sort of fill the role that underscore.find does in Lodash. Although some will argue that Lodash offers a terser variant on the syntax and also works on objects. I think the second argument for me falls on deaf ears. If you're writing code that doesn't know whether it should expect an array or an object, you're writing code that's unnecessarily obtuse. It's going to be hard for developers to understand what's going on. Clear intent is one of the most important things that we can do as developers. Number also doesn't give us much. It gives us a few new things. What it mostly does, and this is kind of important, is it moves some of these global methods off the global object and moves them into the number module. They're actually modularizing the library, the standard library. Math, I'm going to go ahead and respect the fact that some of you in this room may be doing mathematical intense computations in JavaScript, like game development or graphics development, but I am not ashamed to admit that to me, this is pretty much so I'm going to gloss over it and move on. Object has a few things that, in my opinion, the only one that's really important is object.assign. That lets us do mix-ins without relying on a framework or library or writing our own utility function. It's pretty cool, right? It lets us take two or more source objects and create a new object by mashing them together one at a time from left to left, right? It's really cool, but be careful because there are a few caveats here as well. The first of which is it's not immutable. It copies over primitive types by value and everything else, which is everything else in JavaScript, by reference. So you'll notice here that we are calling object as .assign and getting a target object, which is a brand new object. But if we manipulate anything that's not a primitive type on the resulting object, we will manipulate the source object. So be careful. It also doesn't copy over anything from the prototype chain. Here's a simple example of how to go one level deep up the prototype chain. So you got to write it yourself. If you want to go further up the prototype chain, you should really be carefully asking yourself if you need a prototype chain that deep. Composition over inheritance. All right, we've talked about syntax, we've talked about enhancements. Now let's get into the good stuff, which I think is really the most important stuff that represents ES6, and that's these new features. And we'll start with iterables. Sorry, I mean iterables. So JavaScript gives us, ES6, sorry, gives us a new interface. Right? We all know JavaScript doesn't have interfaces. If you're using TypeScript, you have interfaces, but that's a whole other language. And basically what it is, it's a contract. And it says that any object can implement a method that's keyed by this here. Don't worry about that just yet. We're going to talk about symbols in a minute. But let's just say it's a well-known method. So as long as you implement that, you can produce that and iterator. And that iterator has a single method next that returns an object that has a value of any type and a Boolean representing whether it's done, right? So it basically says that we can ask to get the next item in the collection without knowing anything else about the collection until either it's done or we're done, right? So what's really cool about this is it lets us be lazy, right? And everybody knows that good developers are lazy, right? We all know that, right? So to that end, laziness, instead of having to implement that or invoke the iterator method, the simple iterator method, or call next on it, they give us this really nice little terse syntax, for up. We all know for in, for iterating over the keys in an object, or the indices in an array. For up does the same thing for values. And it's really clean, it's really concise. But what it's actually doing under the hood is it's invoking that iterator method, or the simple iterator method. It's getting the iterator, and it's calling next until it's done. It actually looks kind of like this. That's what's happening under the hood. So I mentioned earlier the spread operator. It turns out the spread operator, just like for up, also consumes iterables. And all of the built-in collections in the language implement simple iterator, including strings. So here's a novel approach to string.split. It's far more syntax than you need. But the point being, this part right here, the point being this part right here is that we can consume any iterable and spread it out with the spread operator. Now, as I said, all you need to do to make an object iterable is to implement simple.iterator yourself. But it turns out there's a better way. And that way is with generators. So generators are functions that can be paused and resumed. And they have three primary roles. The first role is as producer. Producer of what? Iterables, right? So with generators, we can do really cool things like lazy filtering of a collection. So in this example, we have two generator functions that are combined together by providing the output of one and the input of another. We consume them with a spread, and what we can do here is we can lazily take the first three even numbers out of this collection, which means that as it's iterating, it never gets past 6. Now this is only a 10-item array, but imagine if you had a large array, right? We can extrapolate, and we can do lazy filtering and manipulation of collections without the overhead. We don't have to filter the whole collection. It's really quite a powerful idea. The second role of generators is as consumers. So those generator functions can also take in values, right? And so we can do things like consume any iterable. We have this consume function here that takes an iterable and a generator, and one by one consumes those values. In this case, it's sort of a contrived example. We just log them out to the console. But there's powerful things we can do here, which leads us into the next role. The final role for generator functions is they can work as coroutines. They can both produce and consume values. And the most popular and most important application of this is asynchronous generators. So I'm not going to spend a lot of time on this slide. If you have questions about it, please feel free to ask me afterwards, but I will give you some context. This is a vastly simplified pseudocode version of some code in our code base. The problem we were trying to solve is we have our product as a touchscreen kiosk where you can order food, right? And it has to interact with peripheral devices like scales and scanners and magnetic swipe meters and things like that. And because it's a web app, it can't do so on its own. So we have it talk to a RESTful Java service on the same machine that has the drivers that actually talks to those devices. And when the system comes up online, right, the kiosk asks through that web service to gain control of all those devices. And we expect some failures while those devices are coming up online. So the REST service sends back failures. And what we do is we want to retry up to a certain threshold, after which we think there's really a problem and we've got to do something about it. But we expect a certain number of failures. So previously we had, big module, we had a module level counter variable. The got incremented every time a promise was rejected, and we had a couple of different calls to send out the promise and get back the value and update the counter. It was ugly. It worked, but it was ugly. It relied on essentially global variables. It was hard to follow. And what we get with an async generator is a for loop, which is basic procedural programming and easy to understand. And what this abstraction really gives us, and the real power of asynchronous generators, and a further abstraction that's dropping this June in ES6, which is async functions in the await keyword, which further codifies this abstraction. What it buys us is the ability to treat asynchronous operations as if they were synchronous code. And that is worth everything else in the ES6 spec, in my opinion. Okay, so we mentioned symbols briefly, the symbol.iterator, right? So symbol, what it is a guaranteed unique identifier. It's the 7th primitive type in JavaScript. It's a new primitive type. And it's a unique identifier, right? And its primary purpose is to identify sort of reserved methods on objects. So one of those well-known symbols, as they're called, is symbol.iterator. It's a reserved identifier, right? That's its primary purpose. But there is an interesting other application for symbols, right? And that's we can actually achieve now, until we get property access modifiers in JavaScript, we can actually achieve a true private property. This is a real private property, right? The way that works is we have this single iffy, right, that returns this class. That iffy gets invoked once. So it only ever creates a single closure, and that closure holds this name symbol. And every instance of this class that gets created closes over that name symbol in its constructor. At that point, we have a truly private property. Okay, another really important new feature that we get, and I think arguably another one of the most important features we get is proxies. They're not that well understood. They're not exactly like a web proxy, but I figured most people are familiar with the web proxy, and it's a reasonable enough metaphor. It falls down, but it's a reasonable metaphor from which to start. When we talk about proxies in ES6, what we're really talking about is reflection. Right? Or more specifically, proxies add to our reflective metaprogramming toolkit in JavaScript. So what is reflective metaprogramming? It is a way to inspect and change the structure of a running application. Right? And it breaks down into three parts. Right? The first of which is introspection. So introspection is the ability to inspect the structure of a program while it's running. And we've had this since ES5 with things like object.keys. Right? The second type of reflective metaprogramming is self-modification, right? Which is the ability to change that structure while the program is running. And we've had this also in ES5, since ES5, with things like object.defineProperty. And the last type of reflective metaprogramming is inception. Oh shit, sorry. I get confused on this. Inception is impossible. What I meant to say was intercession, which is the ability to redefine the semantics of operations in a running program. How do we do that in JavaScript? Well, the most common use case, I think, for proxies is probably intercepting getters and setters on an object, right? And it turns out this, we can argue on the side. We use this pattern in Agilysys, and basically, in a nutshell, what this is doing, we have a source object, we create a new proxy object, we iterate through the keys on the source object, we create a property of the same name on the proxy, and then we define what a getter and setter is. It can either just pass straight through, in the case of the setter, it can do validation, we can restrict access to certain properties based on the user's role, all that kind of stuff. Now, security in the browser is just a facade, you can't really enforce that, but it gives you at least some semblance of restriction. But ES6 with the proxy object gives us a cleaner and terser syntax for doing the same thing. In this case, the getters and setters are one size fits all. Any property that's accessed goes through this handle. But that's not that interesting, right? The terser syntax for what we can already do is not that interesting. It turns out proxies go way beyond that. What you can do with proxies would fill an entire talk. So I can't go into too much depth, but I do want to point out a couple of interesting use cases. One of the things that proxies can let us do is to get paranoid. And we can get really paranoid. We can do things like a revocable proxy, or at any point after the proxy is created, we can take it back, right? So in this case, we have a revocable proxy that it gets revoked anytime a user tries to set a private property. It's just by convention, people in the past have used an underscore. So any property that starts with an underscore, they try to access it with a getter, or well, in this case, a set. It immediately revokes access to the proxy. And not only is it paranoid, it's rude. It doesn't even throw an error. It just revokes it, and the next time they try to access anything on that proxy, it throws a type error, right? So it's rude and paranoid. It's kind of like a systems administrator proxy. Another interesting application is that we can, since functions are objects, we can intercept function calls, right? So probably a common use case for this would be like logging out the arguments that are passed to any function that's invoked in the proxy. But we can go further than that. And in this case, we are giving an alternate expression of the same result that you would get by currying the function, right? So instead of pre-binding and sending back a new function with a pre-bound argument, instead of creating a new function, what we do here instead is we just intercept the call the function, and then do something with it, right? There's a ton of applications for that. And the last one's kind of more novel. This is something I'm working on in a sandbox project at work. And it was inspired by a blog post by Dr. Axel Rauschmeier. If you don't know who that guy is, go Google him. He's kind of a brilliant guy. He's written a couple of really good books on ES6 and ES5 and others. He speaks all around the world. And the idea here is that we're going to create a proxy on a dummy object. We don't care actually what's happening with the dummy object. What we want to do is we want to treat the JavaScript object as a web service, right? Now the metaphor is not great, but it's pretty effective. We basically are going to intercept any get on this object. So it can be any property because the source object has no property, right? If it's a get, if it's a put, post, or delete, it's going to be a method call. Because again, accessing that property, even if it's a function, it's still a get, right? So we're just going to return a function that forwards to fetch for us. But the really interesting part, I think, is this one, right? For a get, we're just going to assume that any arbitrary property that somebody tries to access on this proxy is the path of a web service call, and it returns a promise. So it's got potential. I don't know if the metaphor will hold up, but I think it's worth exploring. I think it's a really novel and interesting application of proxies. Okay, ES6, another really important thing. It gives us native promises. Finally. Well, actually, finally didn't make the cut. Neither do a lot of other robust APIs that developers are used to from third-party promise libraries. But look at it this way. Canceling promises didn't make the cut either, so at least you'll never have any broken promises. But that said, for these reasons and others, a lot of developers still prefer libraries like Q and Bluebird for promises. But I will argue that just like this made simple DOM manipulation possible for a lot of people without needing jQuery, I think this will also solve basic promise usage for a lot of people without having to download a third-party library. And it's a first step. Canceling promises is coming. It's a proposal. There's a bunch of the finally block is a proposal. All these things that we're used to should evolve in time, right? And so it's a great first step. Okay, so we talked about some really cool stuff in ES6, right? It's a big update. It's a major update in the language. And a big update like this doesn't come without controversy. There's always going to be dissenting voices. The first bit of controversy comes around all of this new syntax that we've had, right? Great, okay, we got a bunch of new syntax, but for what? It's stuff that we can already do in ES5, so who cares? Well, I will argue that you should never, ever underestimate the importance of developer happiness. Happy developers are more productive, they write better code, they're more enthused about what they do. So if your developers are happy about this new syntax, you should be too. Also, statistics. There are a number of studies out there that have shown a statistically relevant correlation between the overall lines of code in a code base and the incidence or bugs in that code base. So it should follow, mind you, be in the operative word, that if we reduce the overall lines of code in a code base, whether by syntax or otherwise, we ought to see a corresponding reduction in the incidence of bugs. Another controversy is source maps. So source maps are an amazing tool. They were first popularized by CoffeeScript. And if anyone's not using source maps, they basically allow you to debug the code you've written, even though that's not what's running in the browser, by maintaining a map between the code you wrote and the transpiled code that gets run in the browser. The problem is that in today's world, we go through multiple transformation steps, right? And this is not all. Some of us have JSX in there. Most of us have some sort of a module bundler that adds its own wrapping syntax. And it's really easy for things to get lost in translation. And you end up with a debugging experience like this. This is actually a piece of Agilysys code. This particular piece, no matter what we do, we can't seem to get to debug for us. It could have to do with the version of JS we're using, but that's a whole other tangent. And then there's the mother of all controversies, the class syntax. This one is probably the only really potently divisive update that was introduced in ES6. And I'm here to tell you that JavaScript still doesn't have classes. I know it walks like a duck and talks like a duck. This is not a duck, people. It's just syntactic sugar on top of constructors and prototype chains. That's all it is. Now, as I said, this is a deeply divisive topic. People either love classes or they hate them. There's not a lot of people like myself who are a little more pragmatic and don't state an opinion. Right? I sit on the fence, right? There are some pros, without a doubt. And those include the terseness of the syntax. In fact, if you're going to use constructors and prototype chains, and there's a whole very potent argument against that. Check out Eric Elliott if you want to get a really good explanation of why perhaps you shouldn't. But if you're going to do it, I actually kind of admire the terseness of the syntax. It's more readable than old-fashioned constructors and prototype chains. Just wish they didn't call it class. We don't have classes. The tooling argument is a no-brainer. It makes static analysis and refactoring and things like that easier. But probably the strongest argument that's been put forth by proponents of class syntax is that it makes JavaScript more approachable to people coming to the language from classical or mixed languages like Java and C#. But there are some cons, and they are not as pretty as this guy. The first and most important, in my opinion, is that this new syntax is so different from what's going on under the hood that it stands to confuse the very same class-based notebook developers that you're trying to make the language appeal to. And this was exemplified when I gave my 3-part series on coding exercises, when one of the Java developers just exclaimed out of frustration, "That's not how this works!" So, nonetheless, popular libraries and frameworks like Angular and React are popularizing this class syntax. It's out there in the wild. It's been very well received by this Kafka community. Although with React, I will argue that ever since we got stateless functional components, you should question whether or not you need classes on a component basis and also at all, right? Particularly if you use a state management thing like Redux. But nonetheless, whether you love classes or hate classes, we're probably stuck with it. So in summary, how much of ES6 do I think is just hype? Undeserved hype at that? Well, remember that ECMAScript features are decided by committee. And a lot of the features that ended up making their way into ES6 were actually slated for inclusion into the abandoned ES4, which started work right after ES3 dropped in 1999. So what ended up making the cut, and a lot of stuff didn't for ES6, was very carefully considered by a group of incredibly smart people, probably smarter than most of us in this room. And it's my opinion that ES6 is legit. There's very little in it that is overhyped. So at Agilysys, like I said, it's been a little over 1.5 years since we first dropped ES6 in production. We really have barely scratched the surface. We have made usage of pretty much everything that I've showed here tonight, in one way or another. But there are still things that we haven't touched on. And I'm always looking for opportunities to introduce some of these new updates. But I am a pragmatist, which means that if you ask me whether I see the glass half full or half empty, I will talk to you about relative kinetic energy, the angle of the observer, how light waves move, what's the temperature of the water, shit like that. But the reality is, if somebody else is paying my salary to work on their project, I'm not just going to include things because they're shiny. There has to be a reason, there has to be a good and compelling reason why that tool is the right tool for the job. So what's next, right? We have this, we can all agree that ES6 is awesome, right? So what's next? What should we expect from the TC39 committee? Should we expect revolutionary changes in how we live our lives? Should we expect it to transform the world? Probably not so much. You see, ES6 was the last major update the language will ever see. The TC39 committee has decided to move away from these large updates that take years to produce and years to consume in favor of incremental yearly updates, which is why the official name for ES6 is actually ES2015. They intend to introduce smaller updates every year. And it seems to be working, as evidenced by ES6. This was the last major update. I skipped the slide, sorry guys. So ES2016 includes exactly 2 features, which means that my ES2016 in-depth talk will be really short. ES2017 is a little bit more ambitious and has a pair of amazing features in async and await, and a handful of not so glamorous but still useful features. And this should continue for the foreseeable future. We ought to be able to expect that as features evolve, we can consume them sooner. And then, further complicating things for front-end developers is the advent of WebAssembly, which, for those who don't know, is a new bytecode transpilation target for other languages. Out of the box, it'll be for like inscription type languages. But what WebAssembly does, aside from all the amazing things that we'll be able to do with WebAssembly, the really cool thing about WebAssembly is it lets me say something I thought I would never say in a room like this, which is, if you want to do cool things on the web, learn C. And lastly, I give you ice cream. What does that have to do with ES6, you ask? Absolutely nothing, but I did promise my 8-year-old daughter that I would include a slide on ice cream, so thank you very much. Are there any questions for the peanut gallery? Yes.
If you didn't care about code base size, are there any advantages or disadvantages between using like async and generators versus like RxJS?
That's an excellent question. And actually, I have some experience with RxJS, but not enough to make a really educated statement on that. But what I will say is that they are two fundamentally different paradigms, right? An asynchronous generator, it intends to work on an asynchronous event, essentially one at a time, which is why the function can be paused and resumed. RxJS, on the other hand, is a different paradigm. And in fact, there is a proposal in front of the TC39 committee by Yahar Hussain from Netflix to introduce native observables. And so RxJS, is, for those who don't know, it's part of a larger project by Microsoft. And they have them available for a variety of different languages. And it's popularizing the idea of reactive programming, which is the ability to observe collections over time, right? So streams, for example. And so RxJS treats the problem differently in that it expects asynchronous behaviors to be part of a collection that's delivered over time, and then you can react to that, to the delivery over time. So it's got a lot of potential, and I'm actually really interested in exploring that. We actually at Agilysys are moving away from a several-year love-hate relationship with Angular. And I have to take the flak there because I did introduce Angular. I pushed hard for it back in 2013, and it was the right tool for the job at the time. But we discovered as our code bases have grown and our teams have grown that there are some fundamental problems with the design of Angular, and they haven't really been addressed with the evolution of Angular. It's not a new version of Angular. For those who aren't, I was at NGConf recently, which helped cement my opinion. You know, it was one of the best tech conferences I've ever been to in terms of the content and how it was curated and all the activities they provided. It was a great conference. But I had already been leading away from migrating to the next version of Angular for lots of reasons. You know, React has popularized some really important paradigms on the front end. Component-based architecture, one-way reactive data flow. And in fact, Angular very much, the Google team that created Angular freely admits that React was their primary inspiration, even though, in all fairness, they led the way on the component architecture with directives back in 2009. The way that React implemented it was so much simpler and so much more elegant. And so, with all that in mind, you know, we are starting out right now a brand new project using React and Redux, and I am actually looking at throwing RxJS into the mix. I know there's bindings for Redux with RxJS, but it's an excellent question. And on that note, if there's anyone in here that's using RxJS, any people that have migrated already to Angular, which they're now calling the new versions, which has RxJS as a hard dependency, or anyone else that's using RxJS and would like to come and talk to the group, I have absolutely no doubt it would be extremely well received as a talk. I would be the first person to RSVP.
I might be interested in that.
Awesome, excellent. Any other questions? I'll just in shock. Yeah, John.
Are there any performance issues with using backticks everywhere?
Not to my knowledge, although that is one thing that I want to investigate before I propose that as part of our coding standard. But I'm not aware of it off the top of my head, but I am not the authoritative source on that. So don't go out there and say, hey, Tim said I could use that. Somebody else.
I guess this is almost more of a philosophy thing, but you talked about the new ECMA, how they're not going to go with the big, updates, doing the more yearly ones. Well, I work in support, right? I don't work in engineering, so I deal with the people that have to deal with it at the end of the day. And one of the things that I see, especially with us, because we do credit card processing and all that, is people using old browsers. And it's not that they're just lazy. Sometimes sure, they're lazy, you just don't update. But a lot of times they have like either some custom built script or some, especially when you're talking Internet Explorer, I know the thing that everyone here, Internet Explorer, and built in like Java extensions, stuff like that. Like, do you see that really working? Like, I mean, for me, because I look at it like my immediate thing is people using old browsers. How are you going to deal with that? So now I have code bases that have to deal with. Where am I on ECMA 2017, 2018, 2015?
So it's an excellent question, and it's a very valid question because I think probably 80% of developers out there are in your situation versus my situation. We're really spoiled at Agilysys. Well, at least the teams that I work on or oversee are really spoiled over that. Our kiosk application is a closed system. We provide the hardware, we provide the application. It's actually running Electron now as a shell, and then we can determine what version of the browser we want to use, which means we always use the latest and greatest, and we can take advantage of features willy-nilly. Our products that are customer-facing, in the case of like our customer back office and one of the other teams does a property management system, we manage to negotiate with our clients up front that they have to use modern browsers, or we're not going to support them, which means that they can use all the browsers, but we will not field support calls if they're using all the browsers. It's a luxury. Most developers don't have that. So to answer your question, the beauty of it is that ever since we got these translation tools, and Google led the way with Tracer, but Babel just supplanted it due to its really active community and its kind of rapid advancement. The beauty of it is that when we look at something that has the surface area of ES6, for example, which has a huge number of changes, by translation, it's possible to achieve about 95% of that functionality in fully compliant ES5 code, right? So there are some things that won't transpile, like symbols and proxies and the tail call recursion, which is questionable. It's really just an optimized while loop. But aside from those handful of features, which you're excluded from using, take advantage. And in fact, even for years before the spec was ratified, people were using ES6 by transpiling it fully compliant ES5 code. Now, there are some performance implications. Some of that transpiled code is sort of verbose and might not be optimized, although they've done a really good job, and when possible, optimizing it. So considering the fact that you were able to use ES6 in older browsers via this translation process, the fact that these yearly incremental updates are much smaller means that unless they are things that fundamentally can't be achieved by an abstract syntax tree transformation, it's first of all, it's opt-in, whether you want to use it at all. And second of all, I expect that the vast majority of these enhancements will be available to older browsers via translation. It really is just a matter of whether you want to go that path. But if you already have the plumbing set up, if you're already using ES6, and you're using something like Babel, Babel keeps publishing preset packages for each of the incremental upgrades. So for example, right now, all the modern browsers are fully compliant with ES6 spec, right? Which means that if you're lucky enough to target only modern browsers, you can turn off the ES2015 presets for Babel and only use ES2016 and 2017. And then all your ES6 code gets sent out to the browser as native ES6, and you only transpile the pieces that you want that aren't yet compliant in the browser. Any other questions? Yeah.
So in ES5, a lot of the way that memory was managed was basically a hierarchy of execution contexts. You had your variable and your lexical environment inside of it. With let and block scoping, did that change the way that those environments were set up?
No, it does not change. You still have execution contexts.
So does it then obscure the access to it?
That's an excellent question. I'm actually not sure how the internals work in terms of not allowing access to a block scope variable within the same execution context. It's an excellent question, and one that I would be happy to hear the answer from after you go and find out. Next. Yep. Quick aside. For those of you who are reasonably new or early in your careers, there's a whole lot to learn, and a lot of it has absolutely nothing to do with the code you're writing or the technologies you're choosing. And I will give you a piece of personal advice after doing this for over 20 years. One of the most important lessons you can learn as early as possible in your career is to say, I don't know. Seriously, and you'll save yourself a lot of trouble. People will always respect it because nobody knows everything. And you avoid getting yourself in over your head on something that you have no idea what you're doing. Now, it's always good to be a little outside your comfort zone, right? But if you bullshit your way through something, this is engineering, and someone will call you on it, right? So feel free to say, I don't know, and people will help you. Any other questions?
No.
Answer, man. Gold star. Okay, well, if there's no other questions, I want to thank you guys for coming and hearing me talk. Like I said, we will have on the calendar soon our talk for July, and we really are looking for a speaker chair. I really would appreciate if you guys want to feel like you want to give back to this community. If you're outgoing and want to curate some speakers for us, it would be greatly appreciated. If there's anything else that you would like to see us do for you with this group, please let us know. We are more than open to suggestions. I took over this group a couple of years ago with the intent of making it the best meetup in town.
Pretty good.
I think we're on the way. But we can do better. And ultimately, this is a group team effort. So speak up and let your voice be heard. All right, thanks, guys.